I had a request for a full system tour for my maple syrup system, so let's go ahead and do that. This is the monitoring notebook that I use to monitor the controller. And it's also running a Mosquito broker. You can see it says Mosquito on it, which is used by the controller to send out update messages so that I can monitor them in my office and on my phone. And I'll show you that at the end of this video. The notebook gives me a bunch of debugging and status information so that I can see what's going on. So here on the screen right now, you can see that it's sucking, meaning it's gathering sap from the trees. It's dumped 8 times. There's 248 liters. You can see the status of the float switches and some of the thermometers and some of the pressure sensors and vacuum sensors. You can also see that we've got an IP address, and we're connected to IP, and we're connected to MQTT. And over here on the right, this is a software trace just so that I can use it for debugging. And down here on the bottom is the status of the various float switches. So tote 1 bottom float switch is up, tote 1 top float switch is down, barrel 1 bottom is up, barrel 1 top is down. Those float switches are used to decide what the controller should be doing, whether it should be gathering, whether it should be running the RO, those sorts of things. This little notebook uses a serial connection right here, and it's only receiving. It can't send out. It doesn't have that line. So it's just listening to the controller and displaying these messages. This is the controller. So there's the little netbook over there. This is the controller here, and it's divided up into 5 zones. The top zone here is power. The middle zone is the controller. This is analog inputs. This is digital inputs, and this is digital outputs. So up at the top here, we have an outlet for the little netbook, and then we have the main breaker, and the mains power coming in, and mains power distribution. Then we have a 12-volt power supply and 12-volt distribution, and a 5-volt power supply and 5-volt distribution. This controller, this is a case made by a company called Bud. It has a pair of custom boards in it. You can see the one here on the top with the LEDs on it. This is the top board, and then there's a bottom board. These are both boards that I designed and had manufactured in China. The bottom board has an Arduino Mega 2560 Pro Mini at this end, and an ESP32 at this end. The Arduino does all of the control. It runs this whole thing here. The ESP32 is used only to send messages out to MQTT. And remember, the Mosquito broker is running on this little netbook, and then it sends them out by Wi-Fi so that the control panels in my office can see what's going on, and I can control the system by sending messages back with MQTT. So this is an up close of the I/O. The analog inputs here come from various sensors that are around. So we have vacuum sensors and pressure sensors and things like that. They all come in here. These are digital inputs. So these are all the switches, and you can see TFS is the top float switch, BFS is the bottom float switch, XFS is the transverse float switch. Then we have tote 1 top and tote 1 bottom, and barrel 1 bottom and barrel 1 top. So there's room here to bring in other inputs. I just haven't added them yet. And then over here on the right, these are solid state relays. And what these do is they take the little amount of power, the 5-volt power from the controller, and switch 12 volts on and off to control outside things. So we have the vacuum solenoid here and the air solenoid. The power from those goes directly out to those devices. They're 12-volt devices. Then we have the vacuum pump, the transfer pump, and the RO pump, all of which are 110 volts. So the 12 volts from this solid-state relay goes out to these are DC to DC relays. And then it goes out to a DC to AC solid-state relay in the other part of the room that lets me turn on those big loads. This tote here is my main storage. That's 1,500 liters of storage for raw sap. And then there are 2 200-liter barrels here that I use for concentrate from the RO. So the sap comes in and is put into this tote, and then the RO takes it out of the tote, concentrates it, and puts it into these barrels. There is a lot of plumbing here. So Over here, we have the stuff that's going in and out through the wall of the machine room. The yellow here indicates raw sap. Green indicates vacuum. Black is waste. So where you see blue, that's water. Blue-black is wastewater. Green is vacuum. Green-black is vacuum waste. And then this hose over here is used to send sap, raw sap, out to an outside tote when the main tote is full. And the little white tube that you see here, that's coming in from the outer tote to the RO. On the bottom of the tote here, you see this big black pipe, that's a drain. And this is a dump valve. So if I open that valve there, the contents of the tote dump into this black pipe, which goes out through the wall and goes back to the trees. Coming off the side, there's this stainless steel pipe here that comes out this way through this valve. That lets me fill a bucket here, so I can fill a bucket with raw sap. And then if that one's closed and that one's closed and this one is open, that lets me send raw sap out to the RO. And if that one's closed and this one is open, then the RO is pulling sap in from that tote that's outside beyond the wall. And you can see back in there under the tote, there's a valve there, and there's another one back in there that you probably can't see very well. Those allow me to dump the barrels. So if I open those, the barrels empty out and it goes out to outside. Then this tube here is coming over from the releaser. So the sap comes in, it goes to the releaser, and then it gets pumped up here into the tote. If I close that valve and open this valve, the sap then goes out this way, out through the wall, out to the outside tote. And then you can see right here, there's a drain on the barrel. That comes out over here. So this is for barrel 1, this is for barrel 2. That's barrel 1, and the one behind is barrel 2. And then in between, there's a little crossfeed valve that I can open up, and that attaches the two barrels together. So if this barrel gets full and I need more storage, I can open that crossfeed valve and feed half of the sap back to the back barrel. And it just does that by gravity. This empties out while the one at the back fills up, and then as I add to this one, they both fill at the same time. And then, so this valve here lets me fill a bucket from the back barrel. This valve here lets me fill a bucket from the front barrel. And then this valve lets me send concentrate from the back barrel back into the RO to reconcentrate it. And this one lets me send concentrate from the front barrel, this one, back into the RO to reconcentrate it. So I can pull sap from this tote or from the outdoor tote or from either of these barrels and process it and put it into either one of these barrels. This is a little float site here. It's just a tube, so you can see the Lego dude there is floating. So the little Lego head there is floating, and that just lets me see from a distance what the level is. And I have a camera in the room here looking down so that I can keep an eye on it. It makes it really easy to see what the level is when I see that little Lego head floating. Next up is the RO system. So on the RO system here, we've got a pump. That pump draws out of any one of the sources that I have based on what I set the valves as. And it provides up to 160 PSI into my RO system. And so it comes in here, goes through this one, and then goes up and goes through this one, and up and through, and then out. And the wastewater comes out here and goes out, and I send it back out to the trees. Over at this end of the system, we have this little pump here that's pulling on the wastewater. So the pump over there is pushing the sap in, and then this one is on the other side of the membrane pulling. And the reason that we do that is the way that osmosis works is there's a semi-permeable membrane with sugary water over here and water over here that's been pushed through the membrane. But the water wants to go back. It wants to reduce the concentration over here of sugar, so it will move across that membrane. And that's with a pressure that's called the osmotic pressure. And the way reverse osmosis works is you put more pressure over here than the osmotic pressure, so you push the water back against its will. And the pressure differential over there determines how much water comes across. So this little pump here pulling on this side is pulling the water, reducing the pressure over here, which increases the pressure differential across that membrane and moves the water across faster. This little pump here is called a permeate pump. And then the concentrate that comes out of this hose here, goes up around here and into here. And what this is a bypass valve. So in the position that it's in right now, the concentrate is coming this way into this stainless steel pipe here. If we turn that valve, the concentrate goes out that way. And I use that for when I'm washing. I turn that valve and I wash. Instead of going through the pressure apparatus here, I just go straight out. The next thing up here is a pressure transducer. So this thing reads the pressure in that pipe and sends it over to the controller, which shares it with the ESP32 so that it can send it out. And I'll show you that. So here we are looking at the little monitoring machine again. And the RO pressure transducer, right now it's only running at 12.5 because the RO pump isn't on. But that'll go up to 115 or 120 PSI when it's actually running. Then next to the pressure transducer is a pressure gauge, and we could have looked at that and seen that it was 12.5 just by reading the gauge. And then the next thing up is a Hycalock pressure relief valve. And what that does is that lets me adjust that knob on the, oops, I keep pointing in the wrong direction, this green knob on the end. And what that does, oh, here the RO's just come on. So you see the pressure going up? And what that Hycalock valve does is it lets me dial in that pressure. So we'll wait until the system gets up to pressure here and then I'll mess with it. Right, that looks like it's about it. So if I want to increase the pressure, I can just turn up the pressure there. You see the pressure's going up a bit, and I can also turn it down a bit. Come on, go down, there we go. So that lets me dial in the exact pressure that I want, and it's running well right now at about 115 PSI. So that valve lets me set the back pressure in my RO system, which increases the pressure across that membrane, and I get more water coming out. Now, the star of this show is the vacuum releaser. This is the vacuum releaser. This is the star of the show. This is the machine that pulls the sap in from the trees and starts the whole process going. So the sap comes in through the wall and then comes up through this pipe, through this screen. This is a fine mesh screen that screens out big chunks of stuff and bugs if they manage to get into the system. It comes past a vacuum transducer and a vacuum gauge and then through a check valve. The way that this check valve works, this is a gravity check valve. So when the sap is coming in, it pushes the valve open and it comes through. You can see it's kind of fluttering there. And then the sap goes in. When we release vacuum here, the pressure on this side of the check valve pushes it closed, and the vacuum on this side sucks it closed. So that preserves the vacuum in the trees. And then we have an air transducer and a vacuum transducer. And there's another check valve down between these two tanks here that is open from this tank into that tank. So right now, this tank is under vacuum. So it's pulling that check valve underneath closed, and it's pulling this one open, so the sap is coming in. There's a float switch in there. You can see it right there. That's the lower float switch, and there's an upper one up here. So when that upper float switch goes up, the controller knows that the tank is full, so it shuts off the vacuum. So it closes this solenoid valve here and it opens this solenoid valve, letting air in. That breaks the vacuum. So as the air pressure in here increases, this check valve gets pulled closed by the vacuum in the plumbing out towards the trees. And then the weight of the sap here pushes the lower check valve open and the sap runs down into the lower tank. That lower tank has a float switch at the back of it that senses that there's sap in it. And when it does, it starts this little pump. There's a little wacky pump back here. It starts that pump up, and that pump pumps the sap up either into the main tote, or if we have the valve set properly, out into the tote that's outside for storage. And this machine here, I built from parts that I bought. The stainless steel came from my local hardware store. The sensor came from China, these two sensors. The solenoids came from a company in the US. This gauge here, these gauges came from McMaster Carr, those really nice vacuum and pressure gauges. The valves here, the check valves came from CDL, the maple supplier, and the plumbing came, I think, from Lowe's in the US. The tube is actually a piece of 12-inch water main that I pulled off a garbage pile at a local construction company. I asked the guy if I could have it, and he said yes. The ends I had machined out of Lexan by a local plastic supplier, and the aluminum stand I just put together from aluminum that I bought from my local metal supplier. So this is all homemade. Everything that you see in this room is homemade, other than the pumps and things which I bought. Oh, there, the machine's releasing. So what you heard happen there was the air solenoid was sucking air in as it opened up. And I've got an issue right now where it's not actually, the solenoid isn't opening very quickly, so I'm switching to a ball valve. But you can see that the sap is starting to flow out there as air flows in. It's flowing down to the lower tank. You can see it coming into the lower tank. And the lower tank is actually now pumping the sap. The little pump is pumping the sap up into the machine. And that intermittent noise you're hearing is the switch in the tote as the sap is running in and splashing. The little float switch that tells the RO system that there's enough sap to actually run the RO is going up and down and switching the pump on and off. So that happens. And so here we are looking at the tote, and you can see that the level's kind of fluctuating there as the sap is coming in. So that's the float switch bobbing on the surface. So that's why that's happening. And that sucking noise that you just heard was actually the machine resetting and starting to suck again. And here we're looking at the transfer tank, and you can see the level of the sap is going down in the transfer tank here as it pumps the sap up into the tote for storage. And just a couple of other things that we've got going on in here. So this right here is a Mastercool 90066A vacuum pump. It does 6 cubic feet per minute. It will produce about 29 inches of mercury of vacuum, which is a moderate vacuum. That's been running my system for years. It's a serviceman's pump, so it's only intended to be run for a few minutes at a time while they do service. I run it 12 to 16 hours a day for weeks at a time. I figure it's got several thousand hours of service on it. So it has been an absolute workhorse for me. Now we're looking at the top of the tote. That's the instrument package that I've got built up onto the top of the tote there. And the pipe you see hooking up over the top like this right here, this is an air inlet. This is the sap inlet. And then I have a stem that has a float switch on it, the 2 float switches, one at the bottom and the one at the top. And it also has a laser rangefinder on it, an infrared laser rangefinder that can tell me the exact distance down to the surface of the sap to the millimeter. So I can look on the control panel in my office and see how much sap is in the tote. Now we're in my office. This is my development and testing controller. It's exactly the same as the one that's out in the machine room, except it doesn't have all of the supporting stuff around it. But I develop all of the software on here, test it, and then once I'm happy with it, I bring the outdoor controller in, program it up, and then put it back out in the machine room. This controller also has a Mega 2560 Pro and an ESP32 in it. It has a clock. This is a power supply, distribution, and a breaker so that I can switch it on and off. This is my machine room simulator. This simulates all of the switches and all of the devices that are in the machine room. So these little switches here represent the float switches in the various devices. I've got my vacuum pump, my vacuum solenoid, my air solenoid, my transfer pump, and my RO pump here. I also have the 3 thermometers, inside air, outside air, and vacuum pump temperature. I've got a laser rangefinder that I can use to experiment with the laser rangefinding. And here I have an H-bridge, a 24-volt power supply, and a motorized ball valve that I'm going to use to replace the solenoids because, as I said, in the machine room, the solenoids aren't working very well with the vacuum. So this ball valve, what happens is when it's time to dump, the motor opens the ball valve. And then when it's done dumping, it closes the ball valve. So I use this system for testing to make sure that all of my code is working, that the machine is going to work the way that I expect it to, that the switches are going to have the desired effect, so that I know that the code's going to work when I go out there and I don't end up with a disaster. These two tablets here allow me to monitor and control the system remotely. So I can see that the status is it's actually sucking, so it's pulling sap in from the trees. It's dumped 9 times for 279 total liters. I can see that the transfer float switch is down and the transfer pump is off, and the temperatures, so the inside air temperature is 8 degrees, the outdoor air temperature is 4 degrees, and the vacuum pump's running at 42 degrees, so it's pretty warm. I can see that I've got 23 inches of vacuum, the RO pump is off, and I've only got about 40 PSI in there. So this lets me know what's going on. And over here, these 2 green squares actually let me send a command to the machine to stop doing what it's doing. So if I press this one, you'll see here, the RO pump switches to disabled. So if the RO pump were on right now, it would turn off. And I can do the same thing with the vacuum pump. Because it's running, I'm not going to do that. I don't want to shut it down. And then here I can see the status of the tote 1, barrel 1, tote 2, and barrel 2 float switches. So I know how much stuff I have, or I know that there's stuff in those totes and barrels. So that's a tour of my system. If anybody has any questions, I'm always happy to answer questions. I'm always happy to talk about Arduinos and building boards and building these systems. I really had a good time building this machine. And if anybody has any questions, I'd be happy to talk about the process.